So welcome to the October's Cape Advanced Technology Lecture. And we are fortunate to have not only one, but two speakers today. The two speakers are Quan Deng. He's the director of Huawei Cambridge Research Center. He then joined the Huawei HiSilicon in 2006 and always worked in the digital circuit design, implementation, and the physical implementation. He was the director of Huawei Cambridge Research Center since January 2001 until now. And we'll go back to China soon. In 2020, he built up a computer architecture research lab in Zurich, and after that, he moved to Cambridge. Other speaker is Quentin Liu, and he's a technology planning expert of Huawei. Henry got his PhD from Fudan University in China in 2014, and then worked in the Harbin Institute of Technology at Shenzhen as a postdoc researcher. From 2017, he joined the Huawei Technologies as a senior engineer and principal engineer, project manager, and the technology planning manager. He has published 13 research papers as co-author and held 7 patents. The talk they are going to give today, the title is Introduction of Huawei Cambridge Research Center and the Research on Optoelectronics.
For the introduction, and good afternoon, everyone. I'm very glad to be invited to this lecture, and then we have the opportunity to introduce the current status of Huawei and the Huawei Cambridge Research Center to you, and also, like introduce my colleague Quan. We'll give you some research ideas of Huawei is now interested in for some more details. So. Let me make a brief introduction of what Huawei is doing now and what how are we doing. So, on the several years of very severe restrictions, Huawei is still the leading provider of ICT infrastructure and the smart devices. You can see from the employee scale, we didn't decrease. Actually, we expand. Compared to the very beginning of the team, the restriction starts. So we still have business on more than 170 countries and regions. And the side part is that we go down from number 44 to number 96 from last year. So on the Fortune Group 500, but we're still very high rank. So actually, we invest even more and more in the R&D. We are now the number 2 of the R&D investment of the all around the world. The only one that beyond us is Alphabet, and the one that behind us is like Microsoft, Samsung. They are all behind us. So actually, we have some more detailed digitals on the following page. So and Huawei is very focused on the R&D development. We have more than 50% of the employees are working in the R&D area, including photonics, which is very good at. So that's the general number of Huawei's status. So let me show some more details to all of us. So in Huawei, we focus on the ICT to provide products, solutions, and the services to 3 categories of customers. So there are consumers, which you will know that we are providing the mobile phone, we are providing the set-top box, we are providing the smart TV, all kinds of consumer and the wearables, all kinds of consumer electronics. And also the major business is the carriers. We are still a very leading provider of the 5G, 4G, and even 6G. We are now making some serious investigation and research. And the third category is enterprises. So based on those three customers, we have 6 categories of our business definition, business separation. Actually, you can see to support the carriers, we have the connectivity, and even the devices for the consumer, and also we have the cloud and computing for our enterprise customers. There are some two to emphasize here. The one is the intelligent automotive solution, which in general we don't think is very tightly coupled with the ICT technology, but as the digital car comes, everything changed. So you can see that we are providing the intelligent driving, intelligent sensing, and the smart cabin, and all of related technologies. We think is a very natural extent of our ICT capability. So we're trying to enter this new area since 2 years ago. So there's another all those we can say belongs to the ICT technology, but this one is somewhat different. This is the digital power. Actually, for the digital power, we don't use the traditional CMOS process technology, and actually the capability of all the providers are among all the countries. The capability are almost similar. No one is beyond too much than others. So, and this also is out of the control list, out of the restriction. So now we are providing the smart PV. We have we have the set power, which is tightly connected with our connectivity, also the data center facilities. So we now combine this into a separate business unit, and actually we did very well on this area. I think next year we will achieve the next $10 billion US dollar per year for the revenue, which is also a significant number. So yeah, that's our business. So this, I think we have the number here. I think for the past 3 years, even under this current situation, we still have very solid operation and ongoing investment to the future. So you can see for the carrier business, I think we still have more than 50%. Our revenue is out from China, so we are not just a China market provider. We are still a very international carrier business player. So, and also you can, even under very severe, we cannot access we cannot utilize the ecosystem of Google. We still have consumer business contributed like around the 40% of our revenue. We still have you can see our wearables, our smart screen, upward a lot, and more than 6%. And also for the enterprise, there's not just numbers, all looks promising, which can support our long-term development. So also, because you can see that we still can maintain around the $100 billion US dollar revenue, that provides us with the confidence of investment to the future. You can see this number for the past year and 2021 and even 2020, every year we spend around 20 billion in R&D, which is huge. We especially considering that Huawei is not in the open market, where every money we spend from what we gain from here. So that's according comparing to others is very special. And also you can see the percentage of our R&D investment is around more than 2020. So yeah, that's a draft number to see how we are now investing in the future. So they also are from the business part, it's just a general view, but to support our business is the technical breakthrough behind what we can see. You can see that we have research on mathematical algorithm, to the chip design, to the even materials, and even the cooling system design. Actually, we learned a lot by cooperating with other enterprises and or of course academics. So we have more than 700 people working on the as mathematicians, and we have also more than 5,000 PhDs in engineering. So yeah, also by how to support such technical breakthrough is based on the attracting the talents from all over the world. We are now cooperating with world-class opportunities, like you can see here, Focus and the top companies that we are always on the list. So back on that, also we are not just counting our own employees. We are also driving the industry development through a very open collaboration. I think that's also part of the reason why Prof. Chu asked us to give this lecture to see. You can see here, we aggressively enter into the standards organization to cooperate with other companies. So then we can co-develop the specification. And also we have industrial alliances and also business alliances that we can build the ecosystem. And what I want to emphasize here in this part, yeah, we do also have a very tight academia associations connections with different universities. Actually, Huawei Europe, we set up 27 research centers all around Europe. Actually, every major cities, you can see the Huawei research center there. So what the slogan inside is that where the talent is, the Huawei research center will be there. So also we have different kinds of collaboration style with different universities. Like we have a joint lab, which we will contribute a large amount of money. Generate a technical committee together with the with Huawei and the university sides. Each side contributes some technical member. Then we can co-define what the project is and to approve or sometimes disagree with some proposals. And also we can also co-work with professors separately, project by project. Yeah. Anyway, we have very dynamic solution to support the academia research activities. Yeah, that's how we enter into the community together with the academia. So, okay, someone will be curious that, okay, now you just a general introduction of Huawei company, right? But what Huawei is doing in UK. So here it is. Actually, this story of Huawei UK R&D starts exactly 10 years ago. Late 2012, it's exactly 20 years. They're starting from Ipswich. We acquire a photonics factory from BT, right? If I remember well, it's from BT. And since then, we planning to start to open the Huawei R&D related. We build up offices. We have send the experts to help local people to build up to get familiar with Huawei and to build up the flow and to take over the business, of course. Now, actually, every year, this Ipswich factory provide around 3 to 4 million US dollar revenue for us. It's for Huawei it's not a big amount of money, but they do provide a very critical technology for us. And they will also do more research-oriented activities in overseas research centers. So actually, in Ipswich, we are also trying to build more relationship with Cape, with a university in UK like Cambridge, like Southampton, who are very good at optical technologies. Then 2 years later, we built up the Cambridge office. We sit on the Science Park, 101 and 302. And right after here, because we acquired another company called New, who works on the NB-IoT. And they have the total solution because the NB-IoT is part of 5G specification. So we acquired them and to get familiar with it, also have the chance to enter into the 5G specification definition. So right after that, then we built up a Bristol office. We built up a team working on the CPU. I still remember that we want to develop a multi-thread CPU in Bristol. That's 3 locations. Those 3 offices are all report to Cambridge Research Center, that where I am. So some years as the Cambridge Research Center becomes bigger and bigger, on the side of Huawei's business growing even bigger. Then also AI becomes much hotter than ever before. So in 2017, we built up a London office who works mostly in AI technologies. They have some researchers, several researchers actually working in the AI serial and also the computer vision related technology. Right after that, we built up another research center in Edinburgh who is now working on their database. They are all more like a software technology oriented, like the database, like the operating system and the programming language. So you can see in the Huawei UK R&D, we covers a large range of technologies, which in general I can summarize this. Cambridge is more like chipset oriented. We have the CPU architecture, GPU architecture, and also NPU here, and also we have some compiler technology to different architectures. That's it. And also Ipswich photonics, which I think Mr. Luchan will give us more introduction later. And also Luchan, not just on behalf of the technologies in Ipswich, he will on behalf of the whole high silicon. I think now have more than 10,000 people, right? More than 20,000 people. So London is more AI based research center, and Edinburgh more software based research center. We do cover a large scope of the technology. So yeah, as I just stated, yeah, Huawei just hold the 10-year Huawei UK R&D. Just hold the 10 years anniversary celebration in London this May. You can see we have shows the big the critical activities for the past 10 years, and thanks Professor Chu to also attend this celebration in person. So yeah, in general, I'd like to say that we are here in UK not just for acquire the talents just to absorb something. We are also here. What Mr. Xiang stated in this celebration, they say that the slogan is in UK for UK. Yeah, we are here to also bring our technologies into UK. We are also help to grow up young talents, and we are also providing the working opportunities. We are here to make friends actually. So that's also this one is what our CEO Hank says. Okay, together we can do more. We can do more. So that's the general introduction of what Huawei and the Huawei UK is doing. So let me pass the ball to my colleague, Mr. Quan, to give us an overview of the high silicon optoelectronics. Thank you.
And then we're dreamed to give a speech in the University of Cambridge. So yeah, Professor Chu is Huawei's old friend. And we have had a lot of projects, and some of them are quite successful and give a lot of contribution to our inner projects. So that's, thanks for Professor Chu's invitation today. So let me, based on the research direction of Professor Chu, I'd like to give I picked this topic, optoelectronics, to give an introduction to you guys. So Huawei has 2012 lab, and high silicon semiconductor is a kind of business unit. Under it, there's a branch named high silicon optoelectronics. The headquarters is based in Wuhan. You can see that this is a kind of optical valley we call in Wuhan city. This is the main building in Wuhan, Huawei Silicon Optoelectronics. And this is a new building. It's a bigger one, much bigger than that one. And we have the foundries in 2 buildings. And so for the optoelectronics, we have more than 1,000 employees, and there are 7 research and development centers all around the world. And the revenue last year is beyond 1.5 billion. And Huawei and high silicon optoelectronics are really care about the patents. So we have licensed patents more than 1,300. So I'll give a quick introduction about the business, how to develop. So at the very beginning, in 1999, so the optoelectronics just only a platform in the product line, and in 2012, we decided to start this kind of company, sub-company named Optoelectronics, based in Wuhan. And then during the development, we just support the products in the DC, motor, Ethernet transmission, and access domains. And in 2018, we serve global OTT and the customers, equipment vendors, and enterprise customers. In 2020, we start our new business in the domains of the optical connectivity to optical sensing part. So sensing part is quite important recently for everyone's life. Okay, so as I mentioned, Wuhan is the headquarters of the high silicon electronics. They have the big foundry to do the indium phosphide, gallium arsenide chips, and not only design and manufacturing. And we also do the optical model and some components development. And we also built a competence center within the optical electrical field. And we have some branches in Beijing, Shanghai, Shenzhen, Dongguan, and most important overseas is in the UK, Ipswich. And another one in Ghent, Belgium, called Calliope. It's a former name is Calliope. We acquired it in 19th. So it is mainly focused on the silicon photonics. And we also built the ORFIC, which is the optical radio frequency integrated circuit components center in Milano. So they also offer the DRV, PII, and the CDR products with high performance and no power consumption. And you can see that at the very beginning, as in 1999, we just do this kind of assembly of the products. But with the development of our technology, we do the module, and then we get down to the chips. So we can do the chips now from the silicon photonics to the indium phosphide chips and the ORFIC and the ODSP. We do this kind of vertical integration from a theoretical to the engineering innovation with a very high efficient way to do the expanding of the business. And yeah, we do the optical connectivity solutions in these kind of scenarios. One scenario is commonly is quite traditional, a wide access fiber, optical fiber communication, and even in with the development of 5G, 6G, we are doing the wireless access. and the data center to consider the interconnection between the different board and telecom IP and transmission business. And I'm gonna give you some detailed research points. So firstly, we are focusing on the blue and green red semiconductor laser. What is used for the consumer business, which is about the laser project TV. Recently, quite a hot topic, especially in the market in China. So the problem is that everyone knows that. So the blue LED has a very good efficiency and output power, but for the red one, we also have this kind of a solution to use the possible material to do the color conversion, so we can get good blue and good red output light. But for the green, it seems that there's a gap over there. So if we use white powder to produce the green light, it cannot be fit the requirement of the market, because the efficiency and the power is quite low. And so there's another way to try to solve this problem. So we want to produce this kind of green laser to fill this kind of a gap. But the issue here for the green, it's okay. We use gallium nitride, but for the green, we need to indium in the epitaxy growth process. So, but when we doped the indium into it, it produced a lot of issues about the such as the dislocation and defects in it, which reduce the output power and the efficiency. So how to solve this problem is our challenge. And we are planning to use RGB laser to construct this kind of system. Use alcohols as well to produce a very good quality performance. The big screen. And another topic is that we do the quantum dot light emitting diode. Quantum dot is quite small. It's around 5 nanometers. And it includes 3 parts. One is core, one is shell, another part is a surface ligand. So the core shell, the core and the shell, they are different materials to produce this kind of quantum well to trap the electrons and holes into it. And the best thing is the best thing for quantum dot is that if we change the size, the wavelengths from them are changed. So it's quite interesting and useful. If we want to get the red one, we just synthesize the big one. If we want the blue one, we just synthesize the smaller one. So we use the quantum size effect to produce this RGB, and then we use the different quantum dots to fabricate different device, LED device, and we integrate the device, LED device, with the PFD backplane together to make the uniformed and high resolution display. And this is kind of a demo we did, and this is some lighting on pictures. You can see that. Okay, another topic is about the fast switching LCOS and their applications. The LCOS structure is quite simple. Yeah, industry people like the simple structures because it means that it is stable and cost effective. So LCOS is the structure is simple, but in this kind of scenarios, such as the OTC system, OXC system, and AR-HUD for the automotive driving scenario, and even the laser holographic dicing system, we need this kind of system should be quite reliable. And according to this kind of scenario, we need to its faster speed, and it is uniform and quite reliable in high temperature and humidity. Because this kind of system, we want to use it in the desert, maybe in the very humidity circumstances. So this part is quite important. We are seeking the very fast switching, of course. And another topic is recently hot. It's called photonic crystal surface emitting laser, PIXL. PIXL is a kind of idea to combine the photonic crystal and the semiconductor laser together. So photonic crystal is kind of designed for the photonic band gap to suppress one kind of wavelength output. Just only need just to allow one part of wavelengths coming out and suppress others. So it is a quite good way to give the high power output. So before that, we know there are two kinds of semiconductor lasers. One is EEL, one is VCSEL. They have the different principles. The EEL, which is high cost and fragile, and it has very high power, and but it is difficult to package. The best thing is that it can be brought up later everywhere. And for the VCSEL, it is commercialized used for the iPhone or the other phones for the face recognition. And the principle is that it is low cost, robust, low power, because we don't need the high power in that scenario. Otherwise, it will burn your eyes. And easy to package. And but the weak point is that it is a limited application. But PIXL, it's quite good. They combined the two advantages together, which is low cost, robust, high power, easy to package, and broad applications. So we can see that it's kind of 2D structures. So it's quite easy to do the expanding, such like this kind of structure. If we expanded that and do this kind of matrix, then we do the beam scanning. It is quite useful in the scanning imaging device, such as the LiDAR. LiDAR is also a very hot topic recently for the self-driving mobile. So this is a kind of schematic of a 10 by 10 pixel matrix here. Another topic is a long-term topic. It's an integration of silicon photonics. You can see here it's a kind of interchip optical interconnection posted by Intel, and another one is is from IBM. They published this kind of structure of the future of the silicon photonics. You can see that from the very bottom is electrical parts, so for the processor circuit, and at the very top it is optical components on it. And yeah, if we see this is kind of a simplified schematic. If we see that all the transceiver, waveguide, modulator can be fabricated on silicon, but unfortunately, silicon is not a very good emitting photonics photon material because of its indirect band gap. So the wire bonding is commonly used. Wire bonding 3-5 lasers is commonly used method in the silicon photonics system now. So, but there's a quite brief ideas that why don't grow epitaxy grow the 3-5 materials on silicons? Yes, but it's quite challenging because this is two different materials, so they have some big mismatch between the lattice between them. So there are some kind of ideas to solve this problem. So this one is that one example. We grow the gamma arsenide quantum well and the QD lasers on the V-grouped silicon. So this layer to absorb most part of the dislocations, because if we design this kind of V-groove silicon over there, the dislocation cannot be improved vertically. So it only can go that way. So this very layer absorbs a lot of that. So it's a kind of a smart idea. And another way to finish to fulfill it is to grow the nanowire, but from the fabrication process, it's a little bit difficult because in this part we need to use the electron beam lithography. In industry, we think this kind of process is quite time consuming. So if in the future nano imprint technology is mature, so we can use this kind of technology to produce the large area of patent SOI to do this kind of things. And another one is photo detectors, which is quite new in Huawei Optoelectronics. And yeah, there are two topics. One is we do the traditional silicon. We use the traditional silicon to do the single photon avalanche diode. It can be integrated in the consumer products such as cell phones or your targets such as the watch and the pad, and to make sure that the camera can use in the very weak light, such as 0.02 lux circumferences. And another topic is that we change the material of the silicon to the quantum dots, which is usually is lead sapphire, and absorbs the light and transfer the photon signal to the currents. And this is quite new, and it can be used in the face recognition, even in the dark, in the quite dark circumstances, and also do the security CT for the monitor. This last topic is about the optical radio frequency integrated circuits. So the RF's future is about all the such as LNAPA transceiver and others together, only one chips. So the challenge is here. Firstly, interconnect, how to solve the issues. existed here. So two different chips communication. And another big obstacle is that how to integrate different opponents, such as this is a power device, this is a laser device, and this is a circuit, them together to get this kind of one chip. So I think this is all area electronics focusing on recently. That's all. Thank you.
Very much for the exciting talk and also the introduction of the new research areas and the topics. I can see there are some of the overlaps with the effort and activities here and with many of my colleagues. So now it's open to questions. So maybe I should kick off on this. So we do have people here working on the part of the things in the past, IoT, and Huawei has been pushing much further, connect everything around together. I'm wondering, I did not see a specific introduction of it, but I think it's embedded in your research and also your business here.
Yes, yes. Actually, the MBLT team, the whole team is well embedded in currently in Huawei whole business map, and especially now there are some people still working on the next generation of this the specification of next generation of the community, and also there are some more people working on the low power Wi-Fi chip and chip design. They are also now moved to some new interesting analog design. So, but the major development capability we already moved it back into China, because on the current political situation, we cannot sell 5G based product in UK. So the development team Saturday is shrink little. Yeah.
Two questions. One for you and
Great. Very nice.
the general question that I have is that I'm wondering if Huawei is interested in working in the field of memories of new technology, or if you already work in this field or not. Technology.
Yes. We have a lot of work in memory technology, like the new type of the memory of the, or also like the, we have some study on the serious research on some new type memory, but I cannot share more details. Also, we have like a 3D integration, which is very hot. Research topics, we're trying to combine them. Seems like the HBM, a lot of computing players are using such technology. We are also have such a plan.
Add one more point. Yeah, memory business is quite important in silicon. Yeah, we are developing the NAND structures.
I've got some ideas in this field. Maybe I would.
Yeah, it's welcome.
Yeah, sure.
And the other question, going back to the cortical structure that you showed, it's like just a particle, right? Is that possible to exactly that one? Yeah. Is that possible to make it in another shapes, or is that interesting for you?
Yeah, that's a good question. Actually, if you consider the energy lowest principle, if you put some per circle into the liquid, it's the easiest and quickest way to form the sphere, right? But if you want to take different shapes, you need to get some tricks. When this kind of they call it the ripe process, when it is ripe, sometimes there are two quantum dots combined together, like the how can I switch? Yeah, right. And they do some research for the particle dipole together, but it's quite unique research knowledge. So commonly we use this kind of structure because it's much mass production and uniformity is good.
I was just a simple question, but one of the LCOS device applications, OXC, I wasn't familiar with that. What does that stand for?
Yeah, mainly there are 1, 2, 3, 4 scenarios. One is an OXC system. It's for the optical interconnection. We use LCOS to differentiate different wavelengths to
like interconnects. Okay.
for the
X is for exchange.
Oh, okay.
Is expert in. And another scenario is for the AR display and HUD. AR HUD is a little bit different with the AR because it is you can use a bulky system because you drive in the car is big, not like your glasses, which is quite strict to the volume. And another one is use LCOS to do the dicing. It keeps cutting.
Good afternoon, Dr. Lee. I just a short question about, so you mentioned the pulse switching LCOS devices, right? So pulse switching is about the faster response speed of liquid crystal, or it just fast frame rates of the LCOS?
It means that we need the faster responsible liquid crystal because so generally the response time of the liquid crystal is milliseconds. Yeah, but for some kind of not mature material such as iron liquid crystal, this kind of a material has a very fast response speed, but the weak point is that it cannot be used in the high temperature or the high humidity circumstances. 10 times.
Really
10 times enough.
Yes, and the second question is, I think it's a big problem for LCOS that it has some, so it is it's a phase accumulation system, which requires thickness. Also, it also faces a problem of the limited pixel number of the devices. So, is there any solutions to further reduce the thickness or the pixel size?
Yeah, I don't think the thickness of the liquid crystal is a big problem because from some kind of products of the startup companies, they can do this kind of layer quite thin into your glasses or to make sure that can focus light into your eyes to help some old guys to read papers or something. But it's quite thin. Yeah, we don't. It is from the company, so we don't think it's a big problem or issue. Yeah.
Xing.
3 questions. So you mentioned the fast speed. What kind of switching speed you are targeting at? Targeting at.
How fast is fast?
Okay, it's 0.1 micrometer. Microsecond. Sorry, microsecond. It's bigger is okay, but it's kind of yeah.
The other second question is you mentioned uniformity is a challenge. Could you please like explain what do you mean by uniformity?
Uniformity means that if we for example, if we use it in the I didn't show it, maybe this one. This one is Yeah, it's an example. If we want to use it to make a TV, the human eyes is quite a sensible detector. If some part has a defect over there, and our eyes are very very annoying about that. So the uniformity is very important for this kind of application scenario. Because for that one, it's not sensitive. Because in this system, the component is quite simple. We don't need the big area store component. But for that one, we have to make sure that it has enough pixels over there.
Final question is are you planning to research on optical matter surface, or maybe you have already started on
Match surface. Yeah, we did. We have some projects in Huawei considering to use metal surface, metal surface or metal materials over there. Yeah.
like what kind of application you are using metal material?
Okay. Usually, some kind of functional layer in the optics, or there's some kind of there's a radio frequency scenario. It's also very helpful to change some parts, to change some functions.
Okay, yeah. For your fastest one, you still get full 0 to 2 pi phase modulation? Do you get reduced phase modulation in exchange for the fast?
You mean the alcohols? I have no this kind of information for this part. Sorry.
No problem, thank you.
Yeah, but you can ask me further via my email, and I will answer.
Okay, thank you very much.
Further questions? I think you end up here and send the speakers again.